Okay, so let's go to the velocity of particles in quantum mechanics. So again, we go back to the Einstein-de Broglie relationships.
Sir, is it possible to have a group velocity 0 but other velocity is some number or the opposite?
Yeah, of course. If your particle is going to be is at rest, then the group velocity is 0. Yeah.
Would a standing wave be group velocity 0?
In the case of a standing wave, I don't think there's a notion of velocity.
Oh, I see. Okay.
Okay, so from here we see that V group, it's d omega by dk, is given by dE by dP. Okay. Now suppose that we want to describe a non-relativistic quantum particle. So let's try the classical expression for a free particle, which is E equals to P squared by 2m. In that case, we see that the group velocity is nothing but P over m, which is the velocity of the particle, right? So, this is heuristic, but this basically tells us that our idea of associating the group velocity with the velocity of the particle is consistent with these, Einstein-de Broglie relationship. Okay. So similarly, suppose that we have a relativistic particle. Now, I know that maybe some of you haven't done relativity, so don't worry about it if you don't understand what's happening here. For a relativistic particle, the energy is given by P squared C squared plus M squared C4, the positive square root. Okay. So and now if I plug this into our expression for group velocity, we get V group is PC squared divided by E. Now, energy in relativity is part of a 4-vector. So it is the zeroth component of a 4-dimensional momentum vector. And it's related to the rest energy, which is mc squared, by this factor, which is this velocity-dependent factor. Okay? On the other hand, the momentum is also related to the Newtonian momentum. This is actually the definition of a 3 momentum in relativity by this. So this is the beta factor, right? Beta or gamma factor. I forget which one is which. So if I use this expression in my expression for group velocity, I get, these two factors cancel out, and I have m. So this is not squared. This is just, so mv divided by mc squared times c squared, which is, of course, v. Okay, so things are consistent, okay? So this is basically all the qualitative stuff that I have to say. And next, based on these observations and these ideas, we're going to derive. Derive is not the correct word, but we're going to retrace the steps that Schrodinger took to discover the Schrodinger equation. So before we do that, do we have any questions?